Now we're going to take a look at comparing characters and strings and what exactly are they. To a computer, all pieces of data are just numbers. So what you see in front of you right now is what's called the ASCII table. You can view this at www.asciitable.com, and there's many other sites that have the same table. So every letter, every character, every number, every symbol that's on this keyboard and other things are represented here on this table. And they're all represented by some number. That's the only way computers understand. They don't actually understand a letter, right, per se. When storing it, everything is stored as an integer. So this is everything in here, but I'm going to zoom into one little piece here. Alright, and you can see here, here's our letters. There's the uppercase letters, and over here we have our lowercase letters. Alright, ignoring these three columns, just look at the dec column here, which stands for decimal. The uppercase A has a value of 65. So when it's storing an uppercase letter A, it stores the value 65. But the lowercase a has a value of 97. Right, that becomes very important as we start comparing characters and strings. Okay, so a string really is just a sequence of numbers, right, making up the word. So you notice the lowercase have a higher value than the uppercase values, right, which becomes very important when you're starting to sort data that's either characters or strings. Okay, so let's take a look at a very simple program here. I have two character variables called x and y. I set x equal to the uppercase A and y to the lowercase a. Right? Notice the single quotes because I'm working with characters. Then I have two variables that are strings, first and second, and they have names. Mary with an uppercase M, and second has Mary with a lowercase m. And down below here I'm just comparing x less than y. If it is, then a is less than a. Right? Uppercase A is less than lowercase a. Otherwise, then that means a has to be greater than lowercase a. Same thing down here with the Mary names. Right? So you might think that, you know, lowercase a might come before the other one and so forth. Right? But since the numeric value of these letters and characters in that ASCII table is what drives all this, a is actually, the uppercase a is less than the lowercase a. And then in terms of the names, since Mary starts with an uppercase, it will be less than Mary with a lowercase, right, because the values, right, 65 versus the 97 value, or whatever it is in the ASCII table. So it's looking at the numeric value of the character, right, to see which one is greater than or less than. When it's doing strings, it's looking at one character at a time, so it looks at these m's, and right away it can determine which one's greater than or equal to. All right, so again, it's all based on the numeric values. So I'm going to change one thing here. I'm going to call this one Mary Ann compared to Mary, and I'm not going to change that one up there yet, but so first is now Mary Ann. So in this case, if first is less than second, then Mary Ann is less than Mary, right, with the lowercase m, and this one means that Mary Ann is greater than otherwise. Right? We'll run this program again, and we really shouldn't see a change because I haven't changed the two things that are being compared. Right? For the names, it's actually still comparing the first two letters. You see Mary Ann is still less than Mary. So immediately, because of the uppercase m and the lowercase m, Mary Ann ended up being the less than one. Right? Comes before it in terms of sorting it. But now if I was to change this to an uppercase m, alright, and we'll keep these in sync here, change that to an uppercase m's. Right, and we should get a slightly different result, right? Because now the first letters are the same, so it's going to look at the second letters, which are the same also. The third letters are the same, and the fourth letters are the same. It's not until the fifth letter that there is a difference. And now Mary Ann becomes greater than Mary, because it has more letters in it. The A compared to nothing makes it a larger value, if you want to think of it. Right? It's a bigger string, greater than Mary. So the sorting is very, very dependent on those numbers, right? And might be a little more confusing or lead you down the wrong path if you don't think the right way. You got to think about the numeric values and where they appear in the table. You don't need to memorize the values, but just remember that the uppercase letters come before the lowercase letters, right, when you're sorting. Another thing, some people tend to get confused. If I put 1 in here and 2 in here, let's do it the other way around. Right? 1 and 2. Right? These aren't comparing the value 1 and the value 2. It's actually comparing, right, back to that ASCII table, the numeric values of 1 and 2. So let's find those real quick in here. Oops, I just had it there. Alright, there's the 1 and 2. It's 49 and 50, so we're going to get the right comparison, right? Just because of the order. But again, it's not looking at 1 and 2. It's looking at the 49 and the 50, because these are characters. They are not numeric. I put them in quotes, so that makes them characters. So it will compare them as character values, not as the 1 or the 2. Alright, so you got to keep that in mind as you're going through this. Alright, I'm not going to bother running it because it's the same logic, right? And it's going to work out the same, that 1 is always going to be less than 2. Alright, but it is actually comparing those numeric values in the ASCII table.